Hi, I'm Tammy, and we're here today in Marietta, Georgia to learn about Vhub operations from a practical standpoint or a field standpoint. Vhub is virtual hub. And I want to give a shout out to Charles Spencer, who was so gracious enough to send Ron Woods to teach us today, as well as one of his other techs to train is Kevin Green. I want to thank Jason Gardner, who was so kind to lend us our videographer, the guy behind the camera, and our film editor, Fred Dawson. Thank you, Fred. And I've brought with me James Gregory, and this is our day to train and learn about the Vhubs, so we thought, why not share it with you?
Good morning. This is Ron Woods with Comcast. We're going to be doing a little training video today to show you how we work on the fiber and the Vhubs. But before we get started, I'm going to go over some of the tools you may need to use in troubleshooting. Alright, first tool we're going to start with is the EPM 50 fiber meter, power meter. This will check your light coming into the fiber. You got your power button, you got your frequencies, and you got your dBs, your dBms. So you're going to need this to check your light. You're going to also need a power adapter that you're going to use for your ONU. This is where you're going to use to check your RF when you hook up to the fiber. You're going to need a red light source. Right here, this is a 10 millimeter red light source, milliwatt red light source to shoot your fiber with. You're going to also need a can wrench to open up your FDH cabinet. So you want this in your tool arsenal. And you're going to need APC fiber cleaner, one-click fiber cleaner. And you will need your scissors to cut the fiber with. And always keep a pair of your safety glasses with you when you're cutting fiber. And this is a jumper that I have in my kit for troubleshooting purposes to test the light coming out of the ONU or coming out of the FDH cabinet. And last but not least, this is our Fujikura 22S Fusion Splicer. This is what we're going to be using today to splice connectors. It comes in a kit. You got a power cord, you got your solution spray, you got your straight splices, scissors, strippers, and a battery pack. And this is to support the fiber when you putting a connector on. And it comes with a cleaver. That's your little kit, your CT06 Fujikura cleaver. And you got all your little connectors that you use, your holders for your fiber splicing. As you can see, this little jumper that I use has an APC and a UPC connector on it. You don't want to troubleshoot with this because if you use this for checking your transmits on your DSAM, you're going to get high transmit levels. So first thing we're going to do, we're going to cut this blue connector and put on a green connector so we can use this jumper for troubleshooting purposes. Right now we're going to head over to Stadium Walk where we'll be doing our training for the Vhub, and we're going to get out of this weather right now. It's pretty cold out here. All right.
Do you use this for the ONU unit only?
No, that's a good question.
This jumper, since it has the angle pilot, the APC and UPC connections.
No, you don't want to use it for your ONU because you got two different type of connectors. You got a UPC and you got an APC. You're not going to get good transmit levels out of your ONU if you use two different connectors. You want to make sure both connectors on this jumper are green, APC. You can use it to hook up an ONU, or you can also use it, put it in your little troubleshooting kit as a jumper to test your light or to test out of a unit with.
Okay. So for transmit purposes, you want to use the angle pilot, the green connector, APC connector.
Definitely. Both of them have to be the same.
Gotcha.
So you can get good transmit levels out of your ONU. Got it?
Yes, sir. Thank you.
Okay, we're over here at Stadium Walk. This is one of the fiber properties near Brave Stadium that I work in. If you haven't already experienced this type of network or design in your area, get ready because it's coming. All technicians will be working on fiber. So this is why we're doing this video, so we can get you ready. First thing I want to do is I need to change this connector right here because I'm gonna have to test some fiber, and I can't test it with this with two different type of connectors on this fiber. So we'll prep this jumper right now just for testing purposes. I'm gonna cut that connector off, and put this little tool on this jumper for support when I strip my fiber so it don't suck back in. And once I start stripping, you'll see what I mean. Okay, we're getting ready to put on a 3mm connector, and first thing you want to do is open your little kit up and get your little sleeves. Get your connector and your sleeve. It has to go on. It has to go on first before you can prep your fiber connector.
Do me a favor. Hold those in your hand so I can see them. All right, you good.
Okay, when you put on this sleeve, you want to make sure the spring is pointing in the direction of where you're going to do your splice. So you're going to drop that on, then you're going to put your sleeve on, your other little splicing sleeve. Now, you have to put this on a certain way. You can't put it on in any direction. You have to put the small end with the smaller diameter on first, and the bigger end with the bigger diameter on last, facing where you're going to be splicing. If you don't put this on correct, you're not going to get a good splice. You're going to have to splice it over again. So make sure you put these two on before you start splicing your fiber, or you're going to have to cut it and start over again. So use your tray to measure where you're going to cut. For you beginners that haven't done this, I would recommend that you use a marker, and you can mark it right here. But I've been doing this for a while, so I use my finger to guide me. So we're going to strip that jacket off first. Then you're going to grab the Kevlar. This is called Kevlar. You're going to twist it real tight. You're going to put it on your tray so you can measure where to cut it. I normally grab it right here and pull it like that. And you're going to grab that in and cut the rest of that Kevlar off. You don't want to cut it too long, and you don't want to cut it too short. You cut it too short, it's not going to fill up the tube when you're doing your splicing. If you cut it too long, it's going to hang out of the tube, and you don't want it to hang out of the tube. So you can go back and measure it and see. I think I need to cut just a little bit more off. So twist it. You really need some good scissors to cut this stuff with, because it's hard to cut. Okay, that should be good enough. Okay, now you're going to use your 250 micron. That's the middle stripper, and you're going to grab this fiber up here, because you're only going to do a little bit at a time. You can't do the whole fiber or it won't work. You'll break it. Just a little bit at a time. And it comes right off. Keep going till you get down to the bottom. And this is why you have this little holder on here. You see, when I'm stripping it, if I didn't have this little holder on here, this fiber would slide back through. So that's the purpose of having this holder on here, right here, to keep that fiber from sliding back through the jacket. So we're going to come back here, we're going to put it up here and measure it. We still got a little bit more to cut, because we want to cut it right here where that line comes. And there we go. That should be good enough right there. All right, now we're going to use a different type of stripping tool, so we can get a really clean cut on the 125 micron part of the glass. We're going to strip this glass, and you're going to see the little slight dielectric on the coaxial cable. It's going to come off. Okay, we're getting ready to strip this the fiber core right now with the 125 micron. You probably notice I'm using some different strippers. That's because I'm familiar with this kit, and these work better when you get down to the core. The other kits that you have at your company, they also have strippers in there that you'll be able to use, so you'll be fine. So here we go. I got my light on, my headlight, and I got my bifocals on. You're gonna need those if you're over 40 to help you strip this glass. See that? That's what you want to see when you strip that glass. You want to see that little dielectric come off. Okay, that's good. Now we're gonna come over here, and we're gonna use some alcohol to clean the fiber with. All your kits should have this in it, and you'll have some wipes in your kit. I'm going to take this, soak it with alcohol. No, I don't want to cooperate. There we go. Grab this like that and just swipe it. You can do it a couple of times. That feels good. Okay, now this is where we go and use our cleaver. Let me come over here. I'm getting this ready right now, so when I put my fiber in my little holder, I don't have to look for my cleaver. You want to pull this, push this all the way to the edge and drop it in just like that. You can spin it to get it where you want it. Once you get it in the holders, flip both of these over, hold it in place like that. Drop it in your cleaver. Drop this door over and press straight down hard, just like that. And then spin it, and that's a clean cut. There you go. Now, as you notice, I have my strap on fusion splicer, because you're going to be in some tough spots when you go into these homes, and you're not going to be able to put a table in there. So you're going to need to use these straps to hold a splicer in place. You're going to drop this little holder in here like that, and normally I would have a connector ready, but you can take one out of your little kit and drop it in on the other side. Drop that in there like that. Close your door. Turn your kit on. Turn your fusion splicer on. And you have to set this fusion splicer for 3mm connectors. If you're using 900 micron, you have to set it for 900 micron connectors. Right now I have it set for 3mm connectors. Hit set. It's splicing right there. You don't have to do anything. Sit back. That's a good splice. 0.02. That's not bad. Okay. When you open this up, I normally put my finger right here to hold it in place, because this has a little spring on it. When you release these little latches, it's going to spring back. And then I open this up. I grab the fiber, hold it in place. Grab it with my finger, and then I pull it out just like that. This is the part where you have to be careful, because you got to slide, you got to try to get the sleeve down there without breaking the fiber. Let's see if I can turn that around, because normally you're going to be by yourself, so you can pull that sleeve down once you get it close. Grab it like this and slide it like that. And you see that Kevlar where it meets up to the little connector? That's what you want it to do. You want it to meet. If you can cut it to where it'll meet all the way up, the closer the better. And there you go. You got your sleeve on there. Now you're going to put it in here, your holder. Make sure it's all the way close, because when you drop it in here, you don't want it sliding back out. And you see your little red light? That means it's heat shrinking right now. You don't have to do anything. Just let it sit in there. It'll do the work. Then this light will cut off. That's when you know it's ready. And that's pretty much it to cutting a connector. But it takes practice. It takes a lot of practice.
You can clearly see why it's important to have the small end and the large end in the right places for the sleeve, how it nicely fit into the connector. you have any questions while we're waiting.
What is a good splice? We see 0.02. You said that's good. What are the minimum specifications on this?
I think it's 0 to 0. Anything less than 0.5 is a good splice. I've had a little, maybe 0.6, it works, but you want to keep it below 0.5. Okay, it's finished. You can see, just like in coaxial cable where we had a heat shrink, it does the same thing with the fiber. You can see where it kind of sealed that little tube over there. I'm still close to the connector. It didn't suck out. If it sucks out, you're gonna have to cut another connector. Okay, they got a cooling tray right here. You can set that in the cooling tray. You want it to cool for no less than a minute, because if you try to put that connector on, you're gonna have a tough time, especially with 3mm connectors. You're gonna have a tough time sliding that green connector over this sleeve. It's gonna bind up on you, and you're gonna have to cut a whole new connector. So give it at least a minute and a half. If here's a little trick though, if you do pull the sleeve over, the connector over the sleeve, and it binds up on you, and you're having a tough time, you can reheat it. You can heat it again. It won't damage the fiber. Go ahead.
In the cooling mechanism, do you have to, is it a setting where you have to press cooling? Or
No, it's just a tray you sit in.
Okay.
Yes. While we wait on that to cool, I can get my connectors out that I'm gonna put on here. Okay. Now here's the real tricky part that you want to pay closely attention to. Okay, now that that has cooled off, I can push my green connector up to the tube, and I kind of work it up by spinning it a little bit. It's sliding real easy. Doesn't always work this way, but right now it is working really good. That's how you want it to do. You want it to slide real easy, just like that. Now this is a part that we really want to get right. You definitely have to pay attention to this. On this green connector, you could see a little marker on the black part. You want to match that little marker with this red mark on the white part when you push that connector up close. Now when I push it up close, I'm going to hold it in place, and I'm going to grab the white part with my finger, and now I can pull this plastic off. It comes right off. I'm going to put my little connector on here, and you see little grooves in the top part of this white piece, and if I flip it over, you see it's flat. That's the bottom part. Okay, I want to make sure I get this right. I do not want the bottom part turned up. I want it turned down. I want the top part up with the two little grooves. You see the little grooves up there. You want to match them with that little black part piece you see on there, and that red piece. You want to slide it in straight, and listen. You want to listen for a click. If you hear that click, that's a good sound. That means you have a good connector. You got it on there right, and now you can take this cover part of the connector, and this groove should be up, and it should go over the top part. You just slide it straight. You hear it snap, and you want it loose, just like that. If it's tight, if you're pulling it back and forth and it's tight, you're going to have to cut another connector. Leave this piece on until you're ready to check light. This is just to protect the connector. And that's pretty much it to making a connector.
Good job.
We're going to look at this connector closely so you can see exactly what I'm referring to. These little notches on the top, we call like little bevel notches right here. These little notches on the top, these are the ones I'm referring to where you want facing up in the air. If you can get a close-up shot so you can see those little notches, that's on the top of the connector. Now I'm gonna flip this around and you can see the flat, how flat that is. You want that facing downward. You want the bevel notches up top and you want the flat part downward. And when you take this out and put it together and you go to push this onto the connector, you want these notches going into that red dot. It has to go straight on top. Both of them have to be on top, and it has to slide in like that. Then it'll fit perfect. If you have this upside down, it's not going to work. You're not going to get a good connection. You're going to have to cut a new connector because you probably break the fiber. And always keep this cap right here on here until you're done making your connector. And that's just to keep the fiber safe and clean. Okay, we're going to do some Vhub training here right now. Normally when you come into these new apartment complexes, this is the setup you're going to see. If you don't see this setup when you're troubleshooting, where you don't have light coming to your patch panel or to your apartment complex, you need to find a person who's over maintenance to get you in a room and look for a Vhub. You're going to have to see a Vhub. There's going to be a Vhub in there. It's going to be, this is your Vhub. This is an Aris 4100 Vhub. You're going to also see a cabinet called an FDH cabinet. Fiber Distribution Hub. That's what it stands for. You're going to see a power supply. And you're going to have a lock box in here. We'll go over this in a minute. We're going to have a lock box with this particular design for this building. Some of them have different setups, but we'll go over that in a minute. So right now we're going to open up this Vhub. You're going to use a can wrench. It's a 7/16 nut driver. You can use the brown dot to open this up. We already loosened up the connectors, so no, I didn't leave all the connectors loose. Okay, here's your basic Aris 4100 Vhub. You got what we call a EDFA here on your left. You got your transmitter over here on your right. You got what you call a analog quad receiver up here in the middle. And you got a power pack in here. And this is where your light comes in from the hub. This first connector right here. This is where if you come here, you got power but you have no light. These lights here are not green. Then you're going to check this connector right here. That's the first connector you're going to check for fiber. We want to see around zeros hitting that. This EDFA is an amplifier, fiber amplifier. So you want to see zeros. You can see up to 12 dBm of light coming into here. And that'll be fine. But you don't want to see less than 0 coming in. Okay, if you got good light coming in, you want to see 17s leaving, 17, somewhere around 17, 18 leaving here of light. This light is going to go to your FDH cabinet. This is your FDH cabinet. Now, this particular property, they did a pretty good job. They labeled all the units. Some of them I've been in, they're not labeled. So you're gonna have a little work to do. This is the front panel of your FDH cabinet where your light feeds into the patch panel and it feeds through to your customer's apartment. So this is the front side of the FDH cabinet. We're going to pull this open and look at the back side of the FDH cabinet. That's your back side. These are the drops, the fiber drops that are going to your customer's house. Each one of them have numbers on them, and I'll tell you about those numbers in a minute.
If they're not labeled, how do you find your customer?
We're going to go over that in a minute. So close this and we'll get back to this in a minute. We're going to go back up here to your Vhub. If you ever come to a Vhub and have to troubleshoot, you want to pull power. You do not want to leave power on here when you're troubleshooting this Vhub, because it will blow out this EDFA. And from my experience, it's hard to get EDFAs. Actually, it's hard to get parts to replace in this Vhub. So you want to make sure you pull power. You can, this is your input power right here. You can pull this shunt and it'll shut this node down, and then you can start troubleshooting your light. Okay?
Cut one second. Huh. Do that one more time with the top here.
The power?
Yeah, that's one.
Okay.
I got that. All right, go. When you're ready.
Okay. You can, when troubleshooting for to pull your power, before you start troubleshooting, you can pull your shunt right here. That feeds this node and it'll shut the node down, and then you can start troubleshooting your light.
Are all those shunts supposed to be 10 amps?
They show 30 amp
30?
fuses.
All of them?
Okay. On every last one of them I've been to. You really don't need to check anything up here. Everything is preset already. So what you want to do, if your lights are good at this EDFA, you should have a good EDFA. You shouldn't have no problem right here. Just make sure when you check in light, you not only want to check light, you can hook up a ONU and you can check your RF and you can check your MER and your transmits right here at this fiber. You only want to check light out of here. You don't want to hook up ONU or anything at this point. If everything is good coming into here and you still having problems, you want to come down here. These 4 fiber lines are your different frequencies. They feed into this splitter coming into the FDH cabinet. You can check right here, and you want to also come around. Each one of these have a different splitter. You can pull this whole module if you have to, especially when you're troubleshooting noise. I would recommend that you use Yeti when you're tracking noise, and pull this module and see if your noise drop out. If that don't drop out, then you could pull another module. So this presses down and the whole thing slides out. Try not to take it from this side because you can damage something back here. So try to pull it from this side when you're tracking noise. But back to your light levels, this feeds down going into the patch panel, and that's where you want to see your 0 dBm of light going into the patch panel. Let's say, for instance, I'm working in 1303 and the Vhub is working, but 1303 is not working. So what I want to do is I want to come here to the Vhub. I want to look on my patch. I want to look up here on my door and see if I can find 1303. 1314, 1417, 1120, 1303. There's 1303. Okay, we got 1303 right here. But I don't know where that fiber goes on this patch panel. So there's a number labeled up here, 28. So I'm gonna come down here to the patch panel and look for 28. Here's 28 right here. I'm gonna take this fiber out from the connector. We don't want to pull it right now because this is an active customer. but I want to take this fiber out and I want to hook up my light meter at that point right here. You don't need to check anything up here. You don't need to touch any of that. Just come straight to the patch panel, check your light. If you got light, you want to see around 0 hitting that. That's good.
We were told that plus to minus 2 is acceptable. Would you agree in your experience?
The manual, when I read the documents, it says -3 to +3
So
is good.
plus 3 is good.
It can work.
And that's
Your optimal level you want to see is 0.
Right, there you go. That would be the world of perfection.
Yes.
Okay.
So -3, good question.
Plus-
-3 to +3, you want to see going into here. This splitter does lose. This splitter does have an insertion loss of 17 dB. So when it's leaving that EDFA at 17 and coming down here, once it comes through here, out the other end, that's where it's going to be 0. There you go. So now we down here at the patch panel. We got light going to our customer, but we still can't lock a modem in the customer's house. So we're going to go back to 28. We're going to hook up a ONU at that point to that same drop and see if we can lock a modem. If we can lock a modem at that drop, everything here is good. What I would do then, come back in here, look for 28 on the back side of this patch panel. Okay. Can we find 28? Where's 28? Okay, it's back there. I see it. It's back here. That's when you keep your little fiber jumper with you, and you can plug your fiber jumper in there and check off that port, off that bulkhead. You got your little fiber jumper, hook it up to your ONU. You can still lock a modem. So now at that point, I would plug that connector back in to the bulkhead. I would go to my customer's house. If I still can't lock a modem, I would go ahead and change my connector. You're either going to have an air gap on that end, the customer side, or you're going to have an air gap on this end. Then you should get good results once you change your connector.
So you would change the connector before using an OTDR on it?
I've been doing this for a while. I probably used the OTDR 2 times since I've been doing this. I mean, if you're gonna know if it's bad once you change the connector. If you change the connector on this end, that end, and it still doesn't work, with these designs, you can come over here and you also have a red light that you're gonna hook up in the customer's house and shoot back to this fiber tray. And if you see a discrepancy in the fiber tray, you can splice your connection right here. If it's still bad, then you know you got to change the drop. So you don't really even need to pull out an OTDR. All it's going to tell you is you got bad fiber. Well, you're going to know that once you change these connectors and it's not working. Any questions? Any other questions?
Have you ever had to change a connector on this side?
Never had to. Let me knock on. We got some wood in here. Never had to change a connector in here. So they did a great job. In any of the properties I've been to, never had to change
This
it.
stuff you should never have.
Right. The guys, the contractors who put this in, they did a very good job. All my connectors are normally in a fiber enclosure or at the customer's house where you got a lot of activity going on. Somebody went in that closet, started touching stuff. I'm not going to blame it on the service techs. No.
That could be customers.
Yeah, customers did it.
Exactly.
All right. Any other questions while we're down here? Because this is the part you really need to know about troubleshooting. Like I said, up here, you shouldn't have to really touch anything. These things are reliable. They don't go out that often unless it's power related or something going on in the hub. I normally just check this fiber here, and I check this fiber coming into my splitter. And if this is working and this is not working, my EDFA is bad. Then I'm gonna get in touch with my supervisor and we're gonna go from there.
Do you shoot the red light source from the Vhub to the customers?
You shoot the red light source from the back of your patch panel going into your customer's house, or you shoot it from your customer's house to the Vhub.
Okay.
And either way, your results should appear right here.
Right. Oh, let me go over something while we're on that topic. Just because, okay, let's say we shoot a red light from the customer's house. We see the red light coming in here, but we don't see it going out. We don't see it coming out of this connector, this splice. Does that mean your drop is bad?
The splice might be bad.
What I would do then, before I take this apart, I would go either cut the connector right there. If you shooting it from the customer's house back to the Vhub, I would cut the connector there and check it, hook it back up and check it. If it's still not good, then I would shoot the light from here back to my customer's house. And if it's still bad, cut the connector in the customer's house. This would be my last resort. We just had a situation where we shot back and it was good we saw a good light here, but we didn't see light here. But if I kinked it a little bit, I could see the light. So just because you don't see the light on this side when you're shooting a fiber don't mean it's bad. That's the point I'm trying to make. So at all costs, change connector in here and change the connector at the other end first before you even touch this. There's no need to touch this. Most of them, they did a great job.
Well,
Any other questions? Okay, we can move on to the power. Okay, we're back at the Vhub and we're getting ready to go over doing a loop back at the node. Right now I have an ONU hooked up with a fiber input. You see my green light, I got signal. And I'm gonna hook my RF up to my meter, turn my meter on, go to loopback settings on my DSAM, and we're gonna shoot back 33 at 40 megahertz. And I'm gonna run my other cable on my RF side to my transmitter. And these transmitters have labels on them. They have an A and a B side. We got an analog quad receiver up here that's labeled. We got 1 and 2 going to my A, 1 and 2 going to my A side, and 3 and 4 going to my B side. But we only have 3 hooked up right now to the transmitter, so we're gonna put it in my B side test point so I can see my levels on my loopback. So you want to see, once you shoot 33, you want to see -8 on your meter. You see -8, your Vhub is good. You're not having any problems with your Vhub. You don't see -8, let's just say -12. You're going to go up here to your quad analog receiver and make adjustments with the pot that coincides to the port that you're doing your loop back in. Right now, the number 3 coincides with the B side. This is where we'll do our adjustments on this pot. But since we're reading -8, we don't need to do any adjustments. Everything looks good. At that point, you can call ahead in and set up to where you can shoot back a signal and make sure everything is set up with your transmits levels. Pretty much that's all it is to doing the loop back. Pretty good. Okay, we back at the Vhub and we're going to go over our power supply. Anytime you come into a room with a Vhub, you're going to have a power supply. Well, you should have a power supply next to it. It's got to be here to power up the node, of course. And we also want to see an ONU in here. Some locations you'll see an ONU and some you won't. It depends on the contractor who did the install. And the purpose of that is to, when you get on site, you may have an outage at this location where you don't even have to open up the FDH cabinet or the Vhub. You can open up the power supply, you got power, You open up the power supply and see this ONU in here and see that green light, you know you got signal. Is it good signal? We don't know. You can come here and check off this fiber. It's already installed where you can check the levels right here. If you got good levels, more than likely you got good levels because you have a green light on that ONU. We do have different types of ONUs where sometimes it won't tell you whether the ONU is working. You can have green lights and still not be working. So, but for the most part, you can hook up your meter right here and check your RF levels right off the ONU.
What light level should you see there? Plus, minus 3?
Yes.
All right.
Yes, because remember that's connected coming off the FDH cabinet. That's a fiber jumper actually that was installed just for testing purposes.
Very good.
So that fiber is coming right off the FDH cabinet, and you should have negative to positive 3 of light going into that ONU.
Hey, I got a quick question.
Yes, sir.
If I come into the power supply and there's no ONU unit in there, what should I do at that point?
Well, at that point, hopefully you will have a spare on your truck.
Okay.
You want to carry one of these ONUs on your truck for testing purposes, just in case you come here and you don't see an ONU. You're going to hook it up to a, you can go in the FDH cabinet and open up this panel. Pull that little latch open this panel up, and look to the back side. You'll see some fiber drops going in here. These are spare fibers where they hooked up just so you can use them to test with. You can hook one of these up to your ONU. It should have light on it. You got light on it, then you can hook your DSAM up to your RF port and check off of that. And above this power supply you see a fiber tray. Certain locations they have this design with the tray in it where of course nobody can go in here and do anything other than maintenance, where they'll have to physically pull this open and take these fiber splices out and troubleshoot from this point. Other designs they have, it looks like what we probably would call a fiber tap, and they actually have connectors on them where you can plug in and check off the tap itself, or what we call a RTD, where the fiber connectors connect to. But this design is not like that, so you would have to break these fibers in order to troubleshoot them.
And that would be the last resort.
That's your last resort after you check each side of your fiber drop to make sure your connectors are good.
And how would you do that?
I would go to this panel. If I got, okay, say I got an outage, I open up my power supply, I have a red light, okay? No, I have a green light, okay? I got good signal, but I got one customer that's out.
Okay.
Everybody else is on in the building, but my one customer is out. So what I want to do is look on this panel door and see if they label my addresses right here. Okay, let's say we're looking at 1303. That's my customer that's out. So I'm going to come on this panel and look for 1303. Here we go, 1303. Alright. But I don't know where that fiber is going. I just know I don't have light coming into my customer's house at 1303. I come down here, I look for 1303. I look for, there's above that is a label, a number labeled 28. That 28 is for port 28 on your FDH cabinet. Come down here and you look for port 28 on your FDH cabinet. Okay, there we go, 28 right there. You want to take this fiber, physically take this fiber off, because that's where your light is coming into the panel. You want to hook up your, we're not going to disconnect this because this is an active customer, so we'll just simulate it right now. You're going to hook this up to your light meter, and you're going to set your light meter to 1550. You want to see around 0 hitting that light meter. If you see 0 hitting that light meter, okay, we got good light. Okay, now what we want to do is take your if you've been given a fiber cleaner, you want to take your 1-click APC fiber cleaner and you want to clean that connector with this part of the fiber cleaner. It has 2 parts to it. That's the part you're going to clean your APC connector with. Once you clean that, then you're going to take this off and you're going to clean the bulkhead where you pull your fiber from. They say 1 click, but 3 clicks won't hurt nothing. So once you clean that bulkhead on that side, clean your fiber, you plug that back in, pull this latch open, come to the back. You're going to do the exact same thing in the back. You're going to look for port 28 on your panel in the back. Once you find port 28, there's a lot of wires back here, so you got to be extremely careful when you stick your hand in here. And find port 28, which is located right there. You're going to pull that fiber out. You're going to clean it. Once you take that out, you're going to plug that back in and clean it. Then you're going to plug that fiber back in, go back to your customer, clean that side of the drop. If you still have low signal or no signal, then I would start changing connectors from the customer's house first. Then check your light. If that doesn't work, come back here and clean this part of the fiber. Now, one thing I did leave out, we had I had this jumper right here. That's what I also use this jumper for. When you take that connector off port 28, you could plug this in into that port and then plug the other end to your light meter. And if I got 0 coming in, I should have 0 coming out of the panel. It's good there, then you're good here. We check the drop in the house. Well, we check the drop here, everything is good. We changed the connector in the house. Now we got light, so you know it was your connector. If you don't have light, come back here, change this connector. You still don't have light, the last resort I would go to is your fiber tray up here. This is where it gets real tricky. You're going to have to take this down. Of course, we already shot it with a red light. We know which fiber we're working with. So,
we use the OTDR?
Can we use one?
So did you use the OTDR?
No, I use a red light source.
Okay.
Once I change both connectors, my signal is still bad. 99.9% of the time it's going to be a connector. If you're good at the Vhub, it's going to be a connector. It's rare that you have a drop problem. They do happen. I have had to replace drops before, but if you change connectors and it don't work, you're going to have to pull a fiber. So it's really don't need to use a OTDR. You know, you can if you want to, but I really never had to use one. I just replaced the fiber.
So for the purpose of the video, you shoot the red light source from the inside the customer's house to this panel.
Either or. You could shoot it from, I normally try both sides. So I can see if I have a damage. Because sometimes you can see a damaged piece of fiber when you're shooting it with the light. You can actually see that the light is not passing this connector. You may have to turn off the lights to see that, but I have seen it. And I will cut it right here past the damage point and put on my connector.
Very good. Thank you.
Any other questions?
It's good stuff, Ron. Thank you.
Okay. All right, that's been our presentation of the Vhub and FDH cabinet and the power supply and the fiber tray. It's been really good working with you guys. I hope to talk to you in the future. My number is 678-898-1147. Please give me a call if you have any questions. Thank you.
So we just want to say thanks to Scott McCulloch. We're under his directorship. Bucky Marsh, thank you for allowing us to do this. We hope it helped. It surely helped us. And thank you for your attention.
Thank you.
Okay.
shortcut that.